Good evening, y'all. I guess this new view with the Microstage doesn't have a fancy transition to start things off. Whatever. Transitions are the point. It's just nice to see you all right here on a Sunday evening. We're going to have a good time tonight, I think. I will be, as always, totally candid. This week kicked my butt at work. It's the week we opened our brand new touring Marvel exhibit, which is super cool, if I do say so myself. It's huge. It's excellent. The production value is super high. This is probably the busiest week since I started there a year and a half ago. But that said, within that, got a few evenings to work on some mini movie light stuff, which has been super fun. And I see some of our regular friendly folks in the chat. Hi, good to see you, Thomas. Thomas, you had some cool things happen this week with your. I don't know. Thomas, I feel weird calling yours a large moving light because it's still, I think, on the grand scheme of things, quite small. But yet looking at a 4-inch one to a 12-inch one, that's like a hamster to a ferret, right? You know, that common unit of size comparison, right? Hamster to ferret comparison. Brooke, both good to see you. Chris as well. Hello. Nice to see you all. Thomas, TBD fire. So we're kind of gonna vamp on, what this, tiny kabuki drop that I dreamed up on a whim might be, or how it might work, and maybe build a little bit of it. Dave, good to see you as well. When I see Thomas and Dave in the chat at the same time, I start to get a little worried. I think the two of you have been sort of some of the chief promoters of things catching on fire. That's not to take away from anyone else's love of pyromania here in the chat, but yeah, we'll have a good time, work on some stuff. I think we're going to end up doing a prototype, kind of like we did last week. Do a prototype, do some 3D design, get it printing, and then look at some other things along the way. If that proves easier than I think it will, and things are never as easy, never have on this channel at all, we've been like, hey, let's do a thing, and it takes less time than I want. There are you. But if it does happen that way, I would be delighted, and I have a side backup project, which you might actually be able to. I always forget where the windows are. You might be able to see happening on the mini stage screen here if we watch it closely enough. Of course, now it's not going to do it, but especially in these two central pixels, there is what feels like an intermittent data issue. We'll see if we can get them to flash. Oh, did you see that? Just a little bit of brightness. I know, like before, I have made 0 updates to this crummy camera here, although I did have a thought as to how to make that better. But I think you get a little bit of a flash there. That's like all the LEDs on that star, or a few of them at least, adding an additional color temporarily. So that might be an interesting issue to sort of track down, or it might be a totally boring thing to track down. But I'm pretty sure, I'm not 100% sure, but just given the fact that it's specifically this star, occasionally this one, these are all fed off the same driver board, same power supply, same DMX line. I think if it was a DMX issue, we would be seeing issues up and down the line, right? If this was an intermittent DMX reception issue, I think we would have more generalized issues. I'm looking this way because that's where it is for me. I guess you can kind of see that it's there. Yeah, like I say, I don't think it's a DMX issue. It's because you didn't terminate your DMXs, Thomas. I definitely did not terminate my DMX. In fact, I'll show you in a second what that DMX setup is looking like now. I think what is happening, and this is the process of how we would actually go about tracking this down might be the fun part. And this is, like I say, the side project if we finish the Kabuki project. But what I think is happening is the way that the DMX send or receive functionality works in this project, really, there's two halves of the same coin, is the built-in serial reception hardware on the ATmega 32.8 has a functionality which will call and interrupt bit of code every time it receives a full byte, right? So you don't have to be constantly checking the serial port to see is it high, is it low, and recording this on yourself. It's just a sort of bringing in data from the serial port, and when it has 1 byte, it will throw up an interrupt, so it'll automatically jump to a pre-written piece of code and do something with it. And so you can imagine if you're receiving DMX, what it does is every time it has a full byte, it just says, okay, well, I know I'm supposed to be receiving, byte, say 13 of my 512 bytes of data. I'm going to store that in place 13 in my array. And then return to the rest of your code, do whatever you want, control servos, talk to Neopixels, what have you, wait for 1 more whole byte to appear. Oh, we got another byte? Okay, hang on, whatever you were doing in your code, jump to this bit of code, store byte 14 in its place, and sort of so on and so forth. The thing that I think is happening is the Neopixel data structure is very, very timing sensitive. This is what allows Neopixels to be controlled with only one data line, right? So here, maybe we can, I should have thought of this in advance, but let me pull up a WS2812 datasheet that we can look at together. Yeah, here we go. Let me pull that onto the screen where you can actually see things and put that up here. Yeah, so this is just, I literally just Googled WS2812 datasheet, but for those of you who are not as familiar with Neopixels, I don't know, a lot of you are, all the names in the chat are good nerds, but in case you haven't looked super closely at these things, right, they have essentially, this is one of the little tiny Neopixels like is on our little Neopixel star. Here's one still in a bag, right? So each of these 7 Neopixels that are on this board looks like this. We have VCC, right? We have our power rail. We have our VSS, which is ground. We have our VDD, which is our LED supply current circuit, which is typically in these packages tied to VCC or wired to VCC. It doesn't have to be, but it can. And then you just have a data in and a data out. Unlike lots of other protocols, you don't have a separate data and clock line, where the clock line, when it changes, says, okay, receiving circuit, now this is the moment when this line changes, that's the moment you look at the other line to see what state the data is in. Neopixels is just really one line of data coming in, and because of that, we have to stay within some pretty tight timing requirements. And they summarize them down here, but you have, for most versions of the Neopixels, an 800 kilohertz signal, and if you are sending a 0 in a specific position in your byte, you have a high voltage for 350 nanoseconds and then a low voltage for 800 nanoseconds. If you're sending a 1, it's 700 and 600, right? So a slightly longer on time and a slightly shorter low voltage time, right? So here's a good visual representation, right? Every time you're sending a 0, you send a high and a longer low. Every time you send a 1, you send a longer high and a shorter low. And what I think is happening is that when we go from, that's not quite what I meant, there we go. When the DMX byte comes in, no matter what else is happening, we are jumping to the bit of code that is handling that byte of data. And I think that is occasionally happening in the middle of when the Neopixel code is trying to send out its data at that very specific consistent rate. And when that happens, the data gets truncated. And so I think what we're seeing is like when that, yeah, there we go. When that flashes, it's because it's getting some small chunk of the data that it's not meant to receive, right? It's getting like a little bit of, data that's meant to apply to something else. And the reason that we're not seeing it in any of the other pixels, I think, is because of the way that I've set up the timing. That I think it just happens to be that with the data rate of DMX and the timing of how often I'm updating these Neopixels, it's always going to be mostly in this PCB, could be in this one, occasionally in this one. Mostly it's going to sort of land here. Dave says those timing diagrams look like the inverse of each other. They're close to being the inverse. Let me get this back up. Yeah, so you can see they both, one full bit of data in this data stream is 1.25 microseconds plus or minus 600 nanoseconds, right? So 1200, 600 to 1200 nanoseconds. So actually that's fairly flexible. We just can't interrupt it at any point. And if you stare at these timing values long enough, you sort of see they're not quite inverted. Like they are always spending, on average, you're spending more time in a high voltage state than a low voltage state. I believe that's, oh no, sorry, vice versa. More time in a low voltage state than a high voltage state. But yeah, essentially they are similar to each other, if that sort of makes sense. So in any case, I think that's what's happening, and I guess I'm partly describing it because I don't think it's going to be a thing we solve tonight, but it's kind of an interesting conundrum. I think the solution, and maybe if I implement this, and this is the kind of thing that I think is a interesting problem to talk about, probably not that interesting to watch me dig through the code to try and fix on stream, as we've sort of learned over the past year, digging through code, while an interesting story after the fact is maybe not the most visually exciting, I think. What was I saying? Oh, but I think we could talk about it after it's solved. I think the way to solve it is in the DMX library, there is a hookable function, right? A function that basically gets called every time the receiver receives a full new packet of data, right? So every time it's gotten up to 512 bytes, or however many bytes you're telling it to expect, right? If your receiver is saying, okay, I only want to receive maybe 48 addresses for this application, it will sort of fire this function off after the first 48 addresses of data. And what I think I would do is hook into that function, essentially rewrite that function to, in this specific use case, only update the neopixels after the full byte of data has been received, or the full packet of data has been received. And that would allow us to say that it's always happening at a specific time in relation to the DMX frame. So we'd be updating the neopixels during the mark after break, essentially between the packets of DMX. And I think that would solve our timing issues. So anyway, I'm just rambling about this thing that we're probably not working on tonight, but I think that's going to be kind of an interesting next progression of how to stabilize this. And also, just to sort of forestall, like, if we are looking at this view tonight, which I hope we will be as we're working on the hangers for the Micro-Kabuki, the mini Kabuki, if we will. If you see these guys flash occasionally, now you have my long-winded explanation why. So why don't we dive into that, as tonight's primary project is working on the miniature Kabuki drop. I guess the only other preamble-y things to say are tonight I am drinking a very close-up view of a Little Crazy from Revolution Brewing Company, one of my favorite breweries here in Chicago. It's a Belgio-style pale ale, an exceptionally aromatic citra-hopped wonder. I took a flyer on this. I don't know what to expect from it, but I think it will be... I expect it to be tasty. As always, if you're drinking something tasty on this Sunday evening, always happy to know. No pressure as always. If not, I encourage you to hydrate. Almost never a bad idea, but cheers. Yeah, it's a Belgian style pale ale. It's got kind of that wheaty lightness, but it's also definitely a pale ale. It's very hoppy, without being super heavy, kind of like a wheat beer with hops in it. I should have showed this before I pop the top open, but I like this guy. This guy has big nerd tinker energy, and I'm a huge fan. He's a little crazy. Ooh, Chris is having, what, an Arcalus double IPA? Chris, I don't know that one. That sounds really good. Arcalaus? Yeah, fun. Who's that by, Chris? That sounds like a tasty time. Dave's having from Icicle Brewing Company, Dark Persuasion German Chocolate Cake Ale. Holy cow. Dave, that feels like the kind of thing that you drink like at the end of winter, to clear out before the spring breaks. It sounds like super dark and tasty. Thomas was standing by. Oh, yes. For anyone who's new out there or has forgotten, you could always call me on the emergency phone. The number's at the bottom of the screen, 8150-MALORT. And yes, as always, if you see things on fire that I don't, if I mute myself to sip beer and forget to unmute myself, or if you just want to say hi, the phone is here for that. Really, call anytime. It is truly delightful to get a phone call and not know who it is. It's like a blast from the past for me. Let's see. Broke Both is having, Pink Moscato. Nice and refreshing on the Sunday evening. Riverlands Brewing. Chris suggests, Dave, that you drink it with a spoon. Yeah, there is, so I know some of you are in the Midwest and some of you are in Chicago and some of you are farther afield. Here in Chicago specifically, and I think across the broader Midwest, there is a restaurant chain called Portillo's. They have, it's hard to describe the atmosphere. Imagine the sort of fast casual nature of a Chevy's or a Chili's or an Applebee's, but a little bit nicer, but it's counter serve. You walk up to the counter and they make a lot of tasty things. Hot dogs and pastas and burgers and it's Chicago staples, right? And one of the things they make is a chocolate cake milkshake, where you literally watch them, take their big milkshake maker and drop a piece of German chocolate cake in it and blend it up. And it's the kind of thing. I'm 31. I can barely imagine finishing one of those. When I was a 22-year-old, it was still a heavy experience, and that's the kind of drink it with a spoon kind of experience that I'm imagining that this German chocolate cake beer is for you, Dave, although it sounds really good. Thomas has a cold 40 of water, which I love. That's great. Oh, I should make sure that I have my... Oh, I don't have my water in here with me. That's probably a mistake. Well, maybe Mary can help me out in a little bit. I don't think she's watching tonight, but maybe I'll text her and just see if she'll do me a little hydration favor. Oh, yeah, gonna be a refreshing evening, I think. So let's talk Micro-Kabuki. So let's see, how is the best way to do this? I think until I can get the view of this stage cam a little bit higher quality. And like I said, I have a thought about that for next week, but yeah, we'll show off the truss. I realized I sort of breezed right into like that I have truss warmers here now, like we talked about last time, and didn't sort of like celebrate that fact. Like, that's pretty cool. Enrico's got a polar black cherry seltzer. We love polar black cherry. Oh, never mind. Had a pretzel beer. What's a pretzel beer? That sounds really good. I like a beer cheese with pretzel. That sounds really tasty. Yum. So yeah, so these are some of the truss warmer setups that we were working on last week, and thanks to all of the suggestions that folks had for the various types of mounting hardware. You can see this was me printing out a couple more of those sort of snappy and X plates that we had last time that have worked out super well. And then I have a whole bunch of these, what do we call these? The press plates? I forget what the name was that we came up with these that fit in the end cap here. Excuse me. But that was that's been super successful. So that's what's up in here now. I have 2 of them mounted on these snap plates at the end, and I'd get you a better shot of it, but I don't think this camera's going to focus super well. Oh, maybe it will. Let's find out. There we go. And then right in the middle here, I have 2 of those X plates, sort of casting their light across the center. And though they're sort of static for now, right? Because I was just like, that'll be a... Oh yeah, Thomas, what I plates? T plate? There was something we had a name. It's there, it's in the Fusion files if I feel like being precious about it later. But driving those circuits now, which have lost power for the moment, and you'll see why as I take you back to the table view. Let's see here. I'm going to zoom out a little bit. I'm running into table space and cable length limitations. Just get rid of this keyboard. I don't really need it. And let me hide that, and we'll show you here. So I've got, I think we've seen this before. This is like our, a little tiny, DMX control board, 12 channels, really, really very simple. I think I can do this. Yeah, so we can see me. I wish this was bigger, but, you get the idea. But it's literally just 12 channels of DMX control. It has a page 1, it has a page 2, it has a master for all the channels on a given page. So when I do things like, bring out channels, so channel 1, 2, 3 are RGB in the first truss warmer, RGB, go to page 2, RGB, RGB. Right, and I cannot control all of them at once because I only have 6 faders for those 12 DMX addresses, but I could say set all of the second channel to blue and then set all the first channel to blue. So like I say, it's not at all a full-featured controller, but I do think that I think the truss warmers look pretty good. This camera is doing, frankly, some kind of wild things to the color, although not necessarily in a bad way. It's kind of making them look like more like retro and blown out and saturated than they are in real life. But yeah, that's the setup. I'm really stoked to have some LED light, like, in the trusses, making things look hip and fresh up there. The control for those, let me see. I may not even have enough cable length in this camera to show you what's going on up in there, but let's find out. So, oh God. I apologize for anyone who suffers from motion sickness. You might be, nah, you can't really see. I'll make this better in a future week. Oh, there it is. So this is a little Demilight 095 board up here that's literally just VHB taped to the wall because I know I'm going to rip it out and change it. But it's running off of a little piece of our favorite 4-wire cable. And that is just running back to, will you stay for me, camera? Good. That is just running back to this little board, which you've seen before. This is a little break-in board that has some Phoenix connector positions, has some terminal blocks to make getting power into it easier, also a couple of solderable terminals and a place for a barrel connector. I didn't populate those on this one just because, why? And then I have these 2 leads on the terminal blocks just going back to my bench power supply, which currently is pulling 100 milliamps at 17 volts. So 1.7 watts with some of the Neopixels on, which is a very reasonable power draw. And then the other, this jumper here from this Phoenix terminal, is just coming out of an XLR connector, out of the little cheapy DMX controller, and that's the control. Purpose says, have you thought about editing down past streams into a more condensed video? You know, I have. I've thought about it. Maybe, you know, I should try as an experiment. I feel like for some of these streams, right, the kind of, this is now like, what's the term I'm looking for? Like how the sausage is made. I feel like the kind of content that makes a good condensed, like, video, even if it's like a casual project video, is not necessarily made up of the kind of stuff that I say live on stream, if that makes any sense. Right there, the last little mini, you know, casual update video that I made 2 weeks ago, 3 weeks ago, it's like, hey, here's what's going on, and here's this, and here's that, and it's not necessarily either, you know, shown visually in the same way as this is, right? It's all about the thing itself, and it might not even be the same sort of like narration's a weird word to say, things to be said out loud. So I've thought about it, and I probably should try just to see what the experience would be like, but I'm not 100% sure that, like, there is a, you know, a 10-minute greatest hits version of these streams that's still, you know, valuable. I mean, certainly we take all the parts where things caught on fire and make like a clickbaity, you won't believe what this guy did with his 4-inch DMX moving light, which would be kind of fun. But like in terms of like the experience of this, I don't know that it would be the same. But I'm willing to be convinced otherwise. Like if I am not that big a consumer of recut live streams on YouTube in a video format, so maybe I'm just not familiar with like how those things come together. So for those who do or think it might be useful, let me know. Then let me know what you think. In the comments, in the chat, on the telephone, whatever you feel. Yeah. So that's the setup for the Micro-Kabuki, or for the truss warmers, I should say, at this point, which I think is working quite well. And now that I have a really casual DMX and power run from the benchtop to the Microstage, right now that's a pretty versatile thing to have around. So I could put another one of, you know, a board like this over by the Microstage, and DMX routing issues aside, I could break out power and data to all three of the trusses that are coming pretty simply. And I say three, now eagle-eyed viewers might notice that there's only 2 trusses here, and I have corrected them so they are, if you recall last time, they were using 2 different kinds of mounting hardware, and a little hard to see in the dark here, but I have standardized them. I have enough hardware to do a third truss of the same style and the same size, all the same hardware, but I was sort of holding off in case we wanted to play with it on the bench tonight. But then maybe it will go up. Burpo thinks a good point. Yeah, did something just fall? Maybe I'm seeing things. Burpo says, that makes sense. A little recap with some other voice would be pretty good. See the product as it was made and whatever you wanted to show off on the stream. Yeah, that's a good thought. I mean, it's certainly like what releasing that little mini update video taught me was certainly, like there are people who will consume a 5-minute YouTube video who don't consume before or after the fact a 1, 2, 3 hour stream, and that's totally fair. Like there are certain types of content that I want to watch a 5-minute video of, and there are certain type of content I want to watch a 3-hour stream of. Yeah, it did look like a feather. I don't know what that was about. Oh well, maybe the shop is haunted. Who can say? So yeah, something to think about, Broke Both. Thank you. Always happy to take suggestions, because as I said before, I'm not like a streamer. I stream because I like to share these things with you, and y'all have more eyes and good suggestions for these things, which I super, super appreciate. Which, speaking of, I'm going to need some brain power on this project. Chris says, are you molting? Not feathers, just the usual. So the idea that I had and have, you know, a place to start on this Micro-Kabuki is this guy, right? And the idea is that, so let's say we're looking at it. Hang on, let's do a little desktop tidy up. I'm going to move this controller out of the way, move my power leads out of the way, give ourselves a little room to work here. Okay. So if we were looking at this from the end of the truss, and here's our Micro-Kabuki? Mini-Kabuki? Let's say Mini-Kabuki on the Microstage. How's that? That's a good compromise. So we would have 2 of these units facing each other. The the servo mounting points are collinear, right? So the other one is mounted in the opposite direction facing this. And the idea that I'm operating off of, because as we talked about last week, there's a bunch of different ways you can make a Kabuki drop mechanism, right? A mechanism that drops a curtain on command. But the one I'm operating on, I did a pretty bad job of explaining this last week, I think. But to do more sloppy hand gestures and maybe with a better diagram, here, I'll do this in 3D view, right? If this is my, wow, you can't see that at all, can you? If this Sharpie is a pipe on which a curtain is hanging by means of fingers, in like my experience, it's like a Schedule 40 pipe with some welded bits of metal sticking off of one side at an angle, and you hang your curtain off of those fingers, which naturally wants to pull the pipe down, but you have some mechanism which prevents this pipe from rotating, either a plug or a pin or a what have you. When you allow this pipe to rotate, the weight of the curtain pulls the fingers down, the curtain slips off of those fingers and falls to the ground, right? That's the basics of it. Hey, Palmer, Kabukini. I'm never going to be able to say that after like the first hour, but I like it a lot. So that's the idea of this, right? Is that there's some kind of pipe structure with fingers on it on which the curtain hangs that rotates. Let's see here. So what I'm imagining is some sort of 3D printed pipe structure that affixes to these two servos, these two collinear servos, and has some kind of fingery structure that allows us to, hang some bit of soft goods off of it. But we're also going to need to access this point to attach the pipe itself, or whatever the pipe equivalent is to these servos. And I think that's going to be a little bit fiddly. And here's why, right? I know from my experience with the Demilight, like the connections to the yoke on both axes of that it can be a little bit fiddly to get a nice proper fit on one of these servo units. Not impossible, and I think I have it relatively well dialed in. It'll probably still take just a little bit of filing after the fact. But one of the problems is I need basically a small flange here that mounts to this that the included screw will go through, right? So I need this airspace right here in front of the servo horn to be open because I'm going to need to get a screwdriver in there and tighten that screw. But I also wanted the pipe to be collinear with this axis. So how do I need a clever mounting solution that allows me to keep this free while also maybe either going around or up or what have you to something that is collinear to this. Dave asked a good question, which is why do you need two servos? It's a good question, Dave. I guess, point of fact, I don't. I wonder... I guess I had started with the premise of having two servos just thinking that I would need sort of the holding strength of the two of them to sort of maintain the curtain in its, fingers up and curtain not falling position, right, until this rotates and falls down, which may not be true. It certainly may not be true. There's also, so I would basically have like a servo here and then like some other like maybe passive support at some point, right? That's just sort of suspending it and then I use the servo to turn it. From an electrical perspective, that is certainly a lot easier, right? I think what we'll probably do is let's start building this interface, like how the Kabuki pipe, let's call it, interfaces to this servo. And then when it comes to sort of like building out that idea, maybe we integrate something that can just sort of passively hang. Because that would certainly simplify things. And then if it's not strong enough, maybe we sort of mirror and duplicate whatever this clever attachment method is, which is kind of the meat and potatoes of tonight. And then replicate on that on the other side if we need to. Chris says, could do something similar to a flexible shaft coupler, pronged thing that screws onto the servo and the pipe has its mating part. Oh, I see, Chris. Yeah, so this could be a I think what you're saying, and correct me if I'm wrong, is this could be a two-part design, right? So we'd have something that has the fiddly screw attachment point here that screws in and maybe is a different shape coming off the top. Maybe it's like a square peg, and the pipe part itself has a matching port in it. That's quite clever. Let's see. Dave says the weight of the curtain's so close to the radial center of the pipe, center of gravity very close to the center of the pipe. Yeah, that's the idea, right? Is like to keep everything as close to the center as possible, so that we're minimizing the amount of torque on this servo for sure. Could try a set screw. Would have to be quite small. Oh yeah, so I could do like a kind of a clamping mechanism around this itself. And with either I think, Thomas, what you're saying is like a cylindrical thing that has a set screw that bites into this, which you could certainly do like a little grub screw, or I could have like a two-part mechanism that clamps almost like the strain relief on an electrical connector. That I could certainly do. I kind of like Chris's idea of a small piece that is just, exclusively to bite onto this, almost like an adapter between this and an easier to work with form factor. That's kind of interesting. Another possibility, Palmer's got a comment in here I want to read in a second, but another possibility maybe to stir the pot on, something I didn't do for the Demilight itself, but that I've thought about is, every one of these hobby servos comes with, or typically comes with, 3 different shapes of servo horn, right? So you have the X shape, you have the T-bar, and you have the single arm. Single arm. And I wonder, and these are, injection molded specifically to fit with the right tolerance around this point. And I don't use them for the Demilight because I didn't want to spend this much room on, the yoke arm. I mean, I could have. But I wonder, another way that could go is that, it's something that interfaces to one of these. Part of the challenge there, I could redesign this mounting, right, and give this some more height if I wanted to. But as designed, I don't think that these... Oh, hey, look at that. I was going to say I don't think they clear the bottom, but in fact, they just barely do. So it could be something that mated to, these mounting holes. But then I still kind of have the same problem of before, of what mounts to this has to leave this center hole clear for screwdriver access because I need to be able to get in there and tighten it. Chris is now having flashbacks to my Switch project where I use those pieces and make something over it. Yeah, certainly from a mechanical interface to this surface, this is the simplest thing. Yeah, Thomas used those in your first version. That's right. Yeah, because it's the amount of time I spent fiddling with the fit on the yokes for the Demilight, and the amount of sanding that it still requires is a pain. I don't know for a fact what material this is they use in the hobby servos. It's very slightly malleable. It's maybe... I want to say it's like PTFE or Teflon. I don't think it is because it's not that slippery, but it has a certain malleability to it, which makes this kind of friction fit really easy, as opposed to a hard, PLA or ABS like I'm using. So that could be, there could be something there. Let's see. Thomas says, like the spider couplers, but instead of clamping, it would just screw into the hole on the top. POM? I don't know what that is, Thomas. What did Palmer say? Have you ever been a part of an event with a botched Kabuki drop? It seems like it would be super embarrassing for whoever was at the podium. Indeed, Palmer. Indeed, we have. I think I told this story last week about Kabukis, or 2 weeks ago when we talked about it, but I'll tell it again because I only have, as you all know, I only have 3 stories at a time, and right now I'm working on Kabukis, so this is the one I have. This is when I was working at, I told this story when I was at Looking Glass Alice, working Glass for Alice at Looking Glass, and one of the 7 sections of Kabuki drop failed to drop because the way that we had rigged the curtain around those fingers one time had been basically involved an extra loop around the pipe itself. So we triggered them, and 6 out of 7 curtains fell, and the 7th one did not. So while the actors vamped, I ran into the catwalks and reached over and lifted, this 20 by 20 foot section of theatrical drape sort of up and off the pipe, and then just let it fall to the ground. And I was the manual Kabuki drop for section 7 that day. That was actually the plan, right? That was a thing we had said, if the Kabuki drop doesn't fall and someone's going to run out there to try and fix it mid-show, it's going to be me, the master electrician who has been in the catwalks and knows what's going on, and there's no light cues in that section right after the Kabuki drop falls, and they're going to be vamping anyway. If we need to fly it back in and take it down, we could, but that was kind of an exciting moment. Thomas says, POM is an acetyl plastic. Plastic gear is often made from POM acetyl. Oh, interesting. Yeah, I'd never heard of that, but very cool. It could certainly be. It's not, it has properties that are not quite what don't match with the plastics I'm familiar with. Dave says high density polyethylene, I think is HDPE, yeah? Could certainly be. These might be Googleable questions as well. But the real crux of the point is, right, like, these are made to, I mean, I'm sure they're made incredibly cheaply, right, for how cheap they sell them. But the tolerancing on them is worked out such that this connection is easy in these materials at this tolerance, and it's not easy to recreate, as we've learned. So I wonder if there's something, I mean, okay, so humor me for a second, because I really like the idea of a small coupler that fits to this that then attaches with a separate, simpler, user-defined coupler, if you will, to a pipe. But let's entertain, just for the sake of brainstorming, let's entertain this idea. What is it like if this was a given, right? If this is where we were starting and we wanted the pipe to come off of this, or, you know, it could be one of our other shapes, what would be the coupling method that would attach to something like this? He said, thinking out loud. Let's see. Palmer says, the end of your pipe has a ring the same or more thickness as white spindle. Then you use a larger set screw through that ring. So in that universe, Palmer, and we'll come out, that would be, so like imagine that this itself is the end of my pipe, right? Without this arm on it, this white color here represents the end of my pipe. You're saying put a set screw like basically there, I think, yeah? Is that what I'm understanding? That's certainly a possibility, and I have this sort of shape. I would, I think, like to use its built-in, I guess I'm not married to it, but I've been imagining using the built-in screw hole in the middle. Just because, like, that's the most sort of rigid way. The other thing I found about this plastic is when you side load it, like when you put set screw-like force on it, it does tend to deform somewhat. I'm pretty sure it's the same plastic as whatever this is, and you can tell it's got a fair amount of give. When I was first experimenting with the Demilight yoke connections, these tend to crush a little bit. Collar could be as large as the servo arm. Same ring or thickness as the white spin. Palmer, I'm not 100% sure I'm following, but I suspect you're onto something there. So if you don't mind clarifying a little bit, I'd be eternally grateful. Here, I'll tell you what, I'll do my usual when I ask for questions. This time, when I ask for questions, you know I want a drink. I'll ask you a question, but then, you know, I also get to take a drink. Very tasty. Very bubbly. Excuse me. Yeah, let's see here. Where's our... There we are. New idea, says Palmer. Use existing servo arm. Your pipe ends in a Y flare. Like something that would mount to... like here and here, essentially. Like flares out and leaves this room to get the screwdriver in. I don't hate that. And then maybe it's either like a snap fit or something around here, or a T. Yeah, so it comes down. The trick about a T, right, is that if it comes down, where's the camera view look? If it comes across and then just tees straight out, we're again back to that problem of it's blocking that screw hole in the center. Because once I mate those two parts together, I can't get into that screw. I guess I could screw it in, and then what is the mounting solution to this arm? I wonder if I could do a good enough snap fit with like 4 little bits that went around this. Yeah, snap fit over existing horn, says Chris. Yeah, that's a good way of putting it. I wonder if that's a thing. That could be a really useful structure to have, I could imagine, for a lot of things. That's also, okay, so that's a very small 3D printed part. Honestly, the other idea we're having about like a small connector here to a peg to some kind of socket or something on the pipe is also a small part. So maybe let's mock those up first, or I guess not mock those up, design them in Fusion, and we'll get them printing, and we can explore other stuff. I think that's a good way to go. So, of course, knowing that we were going to work on Fusion in this stream, did I open Fusion in advance? No, of course I didn't. No, of course I didn't. Let me get rid of that. I did, open my timing software. That's, important, but no, it'll take a second to open Fusion. This will be good. While Fusion is booting, I have another piece of cookies truss on my 3D printer just waiting for us. So this is the last piece that I needed to, you're over here. Now, the last piece that I needed to assemble the final electric, if you will. So now I have 3 of these 200mm sections, which is more than enough because an electric in my Microstage environment is 500mm long. So 2 200mm pieces and a single 100mm piece. So that'll be useful to me later. Chris asks, do you preheat the printer? I do, actually. I don't know that it's strictly speaking 100% necessary, but because I have this, semi-enclosed space, I find it like this comes up to an ambient temperature, maybe 10 degrees Fahrenheit above ambient in the office, sort of year round. But I like to think that preheating gets me to that sort of stable ambient. This is really more not about like being a heated chamber, but it's about temperature stability. And so I tend to preheat, and sometimes I'll preheat just when I'm like putting stuff on the flash drive. I'll get it preheating now just so it gets to stable. Like I say, I don't think the absolute temperature makes that much difference, but I do think that having a lack of breeze and a stable temperature does make a difference in my experience. All right, let's get to drafting. So let's see, what are we gonna? I'm rolling over my own microphone. That's no good. Palmer, that's fine, right? Microphones don't mind being rolled over. That's what I think I learned in theater school. So I think I've said before, one of the things that I like to do process-wise when I'm designing a 3D printed part to match an existing part is just to model the existing part first, and then to model the 3D part to it. Like we could just dive right into like modeling the 3D part with our tolerances and such, but I find that this keeps things a little bit more straightforward. So we're gonna make a quick mock-up of this part. So let's see, 34.18. Let's see, is this gonna be? I think this is probably the best view. Yeah, just the biggest. So we will start with a center line, and I think I'm gonna basically draw half of it and then mirror it across the center line. So this is going to be 34.18 divided by 2. There we go. Let's zoom in a little bit there. And we will see at its tip, the radius of that semicircle, the diameter is about 4 millimeters. I'm sure there also exists a 3D model of this somewhere or many somewheres on the internet. GrabCAD would probably be where I would start. But I have found that occasionally there are like differences in vendors' specific models of these little things, even things that are relatively standard, like 9-gram hobby servos and servo horns. So I'm just going to make my own set of measurements here. So that arm is 5.7 millimeters across at that point, and this inner, so let's see, what is the distance between those 2 points? That distance is, I can use the depthing ability of my calipers, the depthing peg, and that is 12.37. So what I have is a point here, I guess I should show it to you, that is 12.37 millimeters divided by 2. Oh, no, this was 5.7 millimeters across divided by 2. And that point is 12.37 millimeters down from the top. So we have that, and that's tangent there. There's something, 5.72 divided by 2. Sorry, that's why this is looking so wrong. There we go. That looks closer to the actual shape of our servo horn. And we'll just mirror this across. Yeah, Chris, we're going to mirror a lot of things off of a lot of center lines as we go. This is a nice symmetrical shape. Chris totally has drafted this piece. Yeah, this makes good sense to me. Let's see here. So that is the point at which these smaller arms start to appear. Those smaller arms are 4 millimeters across and look to be basically non-tapered, right? That looks like sort of a straight out arm. And depth-wise, so I think I'm seeing a measurement error here that I made earlier. Let's get this right. So what I really want is the distance from the end of that arm to the start of this other arm, and that is 13.83 millimeters. Let's correct that. 13.83. There we go. So now, in theory, so this is going to be an overdriven dimension, but let's just see. That comes out to 3.26. I guess what I said really was that, let me delete this dimension. This center arm is 4 millimeters across, so I can just make this 2 millimeters. Thomas has a coupler. Well, I was yammering away. Thomas modeled up a coupler and is going to DM me a link to the Fusion file on Twitter. Amazing. Thank you, Thomas. That's very cool. I'll tell you what, I'm going to finish sketching out the model of this arm, and then I will pull that off of my Twitter DMs and we'll have a look. That's awesome. This is cool. This is what's one of the things I find cool about doing these streams is like it has the potential to be, highly interactive if we want it to be. Chris has a good idea, which is, do I want to print the horn, like print a mock-up of this horn itself, or I could just print the thing it's supposed to match to. The overall length is 5.2, so we will do another line here, and we'll do not a midpoint constraint. Oh, you can't see. There we go. Gonna be one of those evenings, I think. This is 5.2. And the diameter is, again, 4 millimeters. Let's see. Something is not making sense to me here. Something is not coming together. That's 5.2 millimeters from this point, from this arm. Let me get you back there. So that is rather 5.2 millimeters to this edge of this arm. 5.2, there we go. Okay, so now we have an arm that stretches out that way like so, and we have a circular end, which is tangent to that line. That line mirrors across center line. And this circle is coincident to center line. There we go. And now we can mirror 1, 2, 3 shapes across center, and we can mirror 1, 2, 3 shapes across the other center, and we should get a complete shape. So let's just tidy this up a little bit. We'll make that coincident to this circle. That tightens that in, and there, in theory, is our shape that we're matching to. Let's give that a quick save-a-roo. Glass moving light. This Fusion project is still called Moving Light PCB, from back when this was like the first starting off when I was like, maybe I should make a circuit board for the Demilight. So it's cool to be like, did it, solved it, working pretty well. We'll call this Kabuki attachment. Let's see, that's center of the 3.2 millimeter line or tangent. 5.2 millimeter, because I'm not 100% sure I follow, but it is a tangent constraint there. I guess it could also be coincident to this, but since this is a perpendicular line, I think it's going to work out to be the same thing. So now, we'll do this is a silly thing, I just like do a little perspective sanity check. I'm going to hold the part up with my eye and see if there's anything. And of course, I can't, focus on two planes at the same time. Seems close. I do want to verify. I think my smaller circle is too far to the right. Yes, Chris, I understand. Yes, this 5.2 should be where this circle terminates. Right? That should be 5.2 millimeters to this line, I think is what you're saying, which I agree with. Yeah. That, I think, is the thing. Now, why is this not constrained any longer? Unclear. I can't seem to edit it at all. So let's see here. Now, does that track a little bit better with the old seeing eye test? It certainly does. That's not a particularly scientific methodology. I guess I could also zoom way out and hold it up to my screen, but given the number of things on this sketch, that's not a great methodology either. So that'll be what our part, so let's finish that. We'll extrude that horn. The thickness of these is 1.47 millimeters. Yeah, Chris, we're having the same thought. Given how busy that sketch is, it's being a little bit problematic, but let's just extrude this out by 1.47 millimeters, and that's, kind of our servo horn. I guess we should put that center hole in just so we know where it is. Chris says I could extrude and then place it on the screen? Yeah, for sure. This is the same idea as I'm, pointing at my screen, which you can't see, for example. But you can believe me when I'm, holding up the horn to my screen. It looks close. Within, a couple tenths of a millimeter, which for a snap fit part will probably be good enough. Nice. Well, that's a place to start. So before we start designing our own snap-on to this, which might be kind of fun, I'm going to, in another window that's, not on the view that you can see, because, you don't need to be in my Twitter DMs. I mean, you're welcome to be in my Twitter DMs, but I don't want you in my Twitter DMs, if that makes any sense. Is going to download the Fusion file that Thomas just linked me to. Yeah, download. Download as Fusion archive. I will. Not a mandatory field. Send. All right, it will send me an email when it is done exporting. That's very kind of it. Let's see here. Will it send me that email? Again, this is all the Fusion's up on the monitor that you guys get to see. The other one is not for my email is not for public consumption. My inbox is chaos. I will totally admit. So while that is exporting, let me continue over in Fusionsville. So I guess let's put the hole in here, and we'll just make that a concentric hole that we just won't extrude after the fact. And the size of that hole is, I'll keep half an eye on my inbox over here on the other screen. That is approximately 2.5 millimeters, let's say. So we'll just dimension this as, I guess, 2.48 millimeters. We'll finish that sketch, and then we'll just come back into our extrude operation, and we just won't extrude it. So that's what we want to try and leave a little bit accessible. So a snap fit to this, let's say it has, it could just be a diagonal snap, right? It could be a two-sided snap, but I think a four-sided sort of snap arm might be more useful. And again, I think we'll be able to make use of some symmetry. Yeah, Thomas. Yeah, you're welcome. Well, you're welcome, all of you. Anyone who's watching this, whether you're in the chat or not, anyone lurking out there, you're welcome to be in my DMs. I just don't want you to be in my DMs. Does that make sense? So, like I say, we're going to make use of the symmetry of this thing to help us out a little bit here. We're going to design sort of one of these four snap arms, and then we'll duplicate it 4 times, and that'll be useful to us. So let's do the easy part first. So this is going to be, let's say, the part of the arm, and the arm. So we'll sit, basically flush to this part, and then we're going to need down here below the horn a little tooth or grabber or, something that can, slip around this and secure this in place. So, coming back to our top view, arbitrarily, I'm going to say it's this top right arm that we're going to model first, and I will give this an offset. So I want this to be a really tight fit, but of course my 3D printer doesn't have infinite precision, so I'm going to give us like a 0.03 millimeter distance, which is like almost nothing. But I found that the precision is really quite good, just not perfect. Maybe we really want to make it. Well, we'll start with that. We can always modify it. Like I said, the point of this is it's going to be a really fast part to print. So I think that'll be easy enough to change if we find out that that's not the right amount of tolerance. And let's say we want it to be, say, a 3 millimeter arm on either side. And we will extrude just that shape down to that face, make a new body. Yeah, so it's a new arm sticking out there just a little bit. And now we'll make a new sketch on that face. And we'll just bring that shape underneath our arm just a little bit. And by maybe 0.4 millimeters. And by this side, let's say it comes under 0.4 millimeters. I'm kind of guessing at these tolerances. I think this is going to be slightly iterative to get to the right dimensions. You're touching the small wing? Oh, thank you, Chris. Yeah, nope, got it. So now let's extrude this. I wonder what kind of clearance we need. Like how much space do we actually have underneath this horn? Actually, quite a bit. They've got, well, in relative terms, we've got 3.2 millimeters before we actually like start hitting the body of the servo. So let's make this like a 1.6 millimeter overhang, something like that. And then, Palmer says, instead of snapping, what if you made 2 knuckle joints to transfer rotation and just 2 magnets? That's interesting. Yeah, Thomas is all on board with the magnets, and frankly, I am too. I'll tell you what, I would be all on board, except I'll be totally honest. So I have a jar of like 50 small, it's the neodymium magnets. I think I was showing them off the other week that I was using for this project, right? I was doing test fitment of rare earth magnets into 3D printed, like what is the clearance there? How does that affix? And I don't know where my jar is. I don't know where the thing is. And it's not like it's magnetically stuck to something, because the container that they come in is specifically to help that not be the case. You get tummy cam while I have one more furtive look around for them. It's a clear, yeah, I'm saying this like you're gonna look around the room and help me find it. If you do spot it, 1,000 points to Gryffindor. But I'm sure I just stuck it in a container and forgot which one. Chris is stuck to the bottom of the table. Their way that they sell them is in a package that basically keeps them in a small cylinder of plastic inside a much larger cylinder of plastic, so they can't, in theory, get too close to the walls and like stick to things. But yeah, I have no idea where they are. I got them from Menards. I should just buy more. But of course, as you know, the minute you buy more, the original ones are going to turn up. So, Palmer, a super neat idea. Unfortunately, I've failed myself by losing those magnets. Ooh, I see Thomas's file is ready. That'll be fun. Let me finish these arms real quick, and then we'll do that. And by finish, I mean, I think we're just going to chamfer these edges. Is it those edges? No, it's these edges. I want to chamfer, oops. I want to chamfer 1, 2, so that they like slide. Oh, but can't chamfer them that much. Chamfer them a little bit so they slide underneath that thing a little bit easier. I will probably also chamfer this edge a little bit. Just making it, because that's the part that's going to be sort of reaching deepest under this shape. Yeah, I think that's decent. And now we can get about mirroring this. So let's put a mid-plane on opposite sides of this arm. Oh, what happened here? Did I join those accidentally? I think I did. I think I want this to be don't do that. This was, yeah, this should continue to be joined, but I want it to only join to the new body there. Let's see, Chris says, having that snap move diagonally might be harder than it seems. Yeah, we could do like just a unidirectional snap. Like it would only snap across the main or subsidiary arms of the thing. Let's see here. Maybe that's a better place. Maybe that's a safer place to start, at least. So let's see, what would that look like? So I guess it would probably want to, maybe it wants to snap across these smaller arms, because these are kind of beveled in a weird way. So in that case, we'll just take a line from here to there, and we'll make it collinear with that. And then when we extrude, we will nix that shape and just take that. So there's our snapping arm here, which I think is what you were saying. Oh, thank you, Palmer. Palmer, as always, my sound hero. PS cable is, headphone cable is catching on the mic and making noises. Well, great. Here, I'll tell you what I will do is just dress my headphone cable better. Here. Professional stream. With professionals who know about audio quality, so thank you. Let's see. Let's make that mid-plane. Joe Dispro is here and likes the noises. Well, Joe, there's only so much I can do for you. You can please some of the people all the time, or all of the people some of the time. But you can't please the whole sound department all of the time. Oh, and this has become a join again. I want this to be a join just to that. Okay. So now we do a mirror of this body across this plane. New body. And now I need to create a plane that is the mirror line the other way. And I think I can do that. So mid-plane is a relatively powerful tool. Normally I think of it as being between two planes. Two parallel planes, but I think I can take, yeah, so here's two non-parallel planes, and it was still perfectly happy to create a mid-plane between them, which I think is a great feature. So we're going to mirror that body and that body across this plane. New bodies, okay. Let's see, the mirror the face and have it casually float in the air. Yeah, I'm not really sure why. I mean, I'm sure there are workflows where you would. I have never wanted to mirror a face, but that's just me. So now I guess part of the question is like, how much clearance do I allow? So I allowed no clearance here, right, underneath. I probably should add a tiny bit of clearance when I come to join these all together for this. Well, it's going to be tricky for it to be a snap fit that way, but I think... and it's not going to matter because my layer heights aren't going to be very big. I'm going to do this as a straight up, like, sketch on this surface as tight as possible tolerance, and we'll just see how much trouble that gets me in. Let's project this face, and let's bring this down here. And then just so we have something to work with, why don't we create, oh, we'll just make it big. And we will extrude this, and we'll join it to this body, and we'll just give it a couple millimeters of join. So that'll be like the very beginnings of our snap fit. Maybe I'll shrink this down a little bit so we'll be able to see a little bit better what's going on in here. We'll just take sort of the top and bottom off of this sphere. Although we probably do want, how do we want to do this? We'll just start over. That'll be fine. Rather than doing this as a circular design, I think I'm going to use a slot. So we'll do a slot. We'll do a center point slot. Bring it out, an arbitrary distance, and then something like that. That's a nice shape. I'm going to sketch and extrude that and that and that and that and that. So we'll have this kind of pill-shaped thing to play with. Yeah, as a representative. But you do face a mirror. Chris, you're murdering me, Chris. Oh man, we were on a family Zoom call on my mother's side of the family just before this, and the dad jokes flow fast and free on that side of the family, and I love it. My Uncle Dick, my great Uncle Dick, he has been the master of the dad jokes since as young as I can remember. That whole side of the family is just amazing. All right, so here's our snap mechanism. Let me get this printing, and then I do want to open up the file that Thomas sent over, because I just from a quick 3D preview that popped up when I opened it, I think it's going to be quite a different design, and I'm stoked about it. So as usual, I'm just going to save this out as an STL. And let's see, where do we want to put this? In Kabuki, I'll call this Snap 1. Chris, just to recap a thing that Chris asked a few weeks ago, which is a good question, and I know people float in and out. You can, of course, send 3D files straight from Fusion into your slicer of choice. I just like to have basically every STL and every G-code file I've ever generated as reference on file. And so I just save them all. So what I'm going to do is I'm going to leave my settings at sort of the default 0.2 millimeter quality. And I know this interface is a little bit hard to see on the stream, but I'll narrate us through it. But I am going to use the variable layer height functionality, which I have been super into in the past few weeks. We've been printing various shaped things for the museum. Adaptive layer height is a super powerful feature in Prusa Slicer, and other slicers to be fair, where basically it will modulate the layer height based on how much height it thinks it needs to create the certain level of detail at a given layer height. And mostly that's useful for curved shapes, curved or stepped shapes here. But you can see, like, down at the bottom of the shape here where it's just literally vertical walls, it's like, well, let's just do big fat, probably hard for you all to see that mouse over, but it's going to do 0.25 millimeter layers, sort of as tall as I've let the layers go up through this bottom boring part. And then as it gets into these slanted faces up here, right, it's going to dynamically decrease its layer height down to 0.1 millimeters to capture that detail better. And this lets you sort of get the best of both worlds of the speed of a tall layer height and the detail of a small layer height, and it's a really nifty feature that I hadn't really played with much until the past few weeks, and I'm super excited about. This is gonna be a 14-minute print. That's easy as pie. Let us save that out. That's exported. Let me get that printing. Let's see. Palmer's been doing some research on our friend Joseph Dispro. The only relevant video was from the Chicago Shakespeare Theater channel, so I wouldn't trust his advice. Ooh, sick burn. Sick burn in the chat. All right, let's see here. Palmer and Joe and I used to work together. Chris, I knew as soon as I said easy as pie that someone was going to jump on it, and I'm not saying I would have put money on it being you, but I feel like I would be pretty confident in that bet. Let's come into our G-code files. We'll take our snap file, stick it on the flash drive, eject the flash drive. Ooh. Let's see. Ooh, Thomas is looking for the same kind of modulation for extrusion width as we get for dynamic layer heights. That would be cool. All right, 13 minutes and 35 seconds for that print. And as always, I think I've mentioned before, I am super picky about cleaning my bed with isopropyl these days before I print. And I'm just looking for my little rag that I usually do that with, which of course it's probably stuck to those magnets, right? It's probably like I somehow accidentally got a magnetic rag and they're like hanging out together in the corner. Oh, there it is. No rag. I know. Well, so to tell a little, personal story, part of the reason why I'm not going to blame this on anybody else. It's my own darn fault for not being as prepared as I could be. But I will say one of the unexpected things that happened today, though it was awesome, not entirely unexpected, we played through the conclusion of the Dungeons & Dragons campaign that we have been playing. This is the weirdest camera angle. Let's see, what could you look at that would be more interesting than this? Here, you can just look at this. You can stop looking at my sweater and my tuchus while I clean this bed of this 3D printer. We played through the conclusion of our Dungeons & Dragons campaign today, which, after almost 2 years of playing through it, which was awesome. We booked out much of Sunday to make that happen, and we ended up playing for 7 hours straight. And that was awesome. But that did wrap up about 5. Then we had this family call with good old Uncle Dick on it and lots of other wonderful family members. So that was great, but I also sort of jumped into this with only a very small amount of prep today. So, but it seems to be going, well, I don't know about as well as it always goes, I think. Oh no, B. Pauling is unsubscribing from. You're not getting the full Jeff Glass experience that I know you come here for. And that's fair. That's understandable. All right, so that's printing. 14 minutes of print on that. Let's come back over into Fusion, and we can open our Fusion archive file. Let's see here that I've downloaded now, unless it came in as a zip. Here we go. Kabuki dropped that F3Z. Upload into, where do I put this? Kabuki, probably. And again, I know the interface is not as big as it could be for y'all. I guess we'll put it in Moving Light PCB. Oh, select, upload. Thinking about it. It looks like Thomas has an embedded micro servo model in here as well. Should be good. All right, so that is now, should be imported. So if I come over to my data frame, come to my project, and come down to Kabuki drop. Here we go. Oh no, please relaunch Fusion 360. Well, and Fusion has crashed. Thomas! No, it's not a problem. Thomas, I know I have all the good Fusion luck these days. I know yours is not always steady. So if you have just bottled up all of your bad Fusion luck into this file and sent it over to me, I will be so cranky with you. That's all right. I mean, Fusion should update, so I'll just let that do its thing in the background. It relaunched itself, yes. Now I'm curious, because it crashed, is it still going to do its auto update on launch or not? I guess we'll find out. Good time for some refresh. Yeah, I don't know if that's just bad karma or what, but I've been having a really good run. Yeah, Thomas, it's kind of incredible. All right, we'll see if the thing boots back up successfully. Because I'll take a little quick peek at the printer. Yeah, it's fine. We got it. We got the issues seem to have been sussed, which is good. Here, I'm gonna tell you what. I have one. Thinking of Palmer's feedback, I'm gonna do a little. Hopefully that still sounds okay. I just sort of moved it out of the way of myself. Unable to open recovery file. Let's open recovery file. Oop, auto recovery failed. All right, well then don't. I don't want you to recover. Let's see here. Update failed to complete, it says. You can't see that. All right, I'm gonna close Fusion and then restart it without crashing. Yeah, Thomas, no, you're right. The karma is on my end. I'm always like, oh, I'm not having problems with Fusion. No, that's hubris on my part is what that is. Well, Thomas, if I can't update Fusion, I may not be able to open this tonight. I guess I do have the link that you sent. So we could look at it in the online viewer. We'll just see if we can actually look at it in Fusion. But yeah, we'll just let Fusion reboot for a second, see what happens. Hanging out, waiting for Fusion to launch. There we go. All right. It looks like Fusion may have updated because I'm not getting an error here anymore. Let's try this again. This is why, Chris, if you can't open Fusion, do we just call it? This is why it's good to have a backup project. I find it's like, well, if the thing falls on its face, then we just go home. I mean, I am home. You probably are all mostly home too. It's March 2021. Those of you watching this in the future, that's a timely joke. Well, this does seem to be opening this time. So that's a good sign. Hey, look at this. Oh, cool. All right, what do we got going on here? So clearly we've got the servo, right? So let's leave that there for a second. I got two I got a coupler and a pipe. So I get rid of the pipe. Ooh, look at this. So the coupler that goes in there, and then the pipe, which has sort of the mating faces to that, creates a little bit of a rotational effect there. Let's get rid of this servo for a second, see what the inside looks like here. So probably what I would do is modify this just so it has that slightly toothed profile. Oh, except have you... Oh, I see. Yeah. So that's going down onto there. What I have found with these servos is that the sort of toothsome interface, I think I can zoom in some more, is that just putting, because of whatever this slippery plastic, HDPE or POM or PTFE or whatever it is, just putting friction on that top plate is not usually enough for me to get a good attachment. You really do need some of this side surface to be mating as well. So I'd probably build that out and put that tooth surface onto the coupler part there. Screw is part of the servo component, says Thomas. Let's see. Let's have a closer look at this. So if we get rid of the... Yeah, so I think that screw interface is really nice. What I'm thinking, though, is like this smooth surface. I guess I don't know how closely it's been toleranced to the servo itself. I mean, listen, let's be clear. I'm going to print this. It's going to happen. We're going to try it because I would love to be wrong because this is a nice method. But I think what may end up happening, and again, I would love to be wrong, is that we may need to add some friction to this inner surface to help it grip that servo plastic. But we'll find out. So this sort of assumes that the... here, let me turn the parts back on. So this sort of assumes that the pipe is supported vertically by some other structure, right? And then the servo itself is just providing rotational force, because the pipe itself isn't actually fixed to the coupler, right? As far as I can tell, it's just, hey, that's pretty cool. It's just sort of like the ability to rotate in either direction, which I really like. I'm wondering if we maybe want to also affix it to the servo, which I don't think I put as a parameter the first time, but now I'm realizing might be useful. Thomas says, not super printable. Might need to print it with the ear sticking up. Oh, yeah, so I don't know that I think actually it was probably fairly printable, Thomas, because like this inner surface here, let's see, this inner circle is a diameter of 5 millimeters. I think that's well within how well, like this would be a bridge underneath here in this surface, but I think it's a perfectly manageable bridge. So I think that would print probably fine without supports. Thomas says do sectional analysis. Could square one end, says Chris, doesn't need to be round. Yeah, I think it could print in, I would bet at least the Prusa would probably print fine with it in, if I can get this right, like this orientation, right? Like if the bed is down, I would help if I showed you the computer screen, huh? When I'm talking about it. If this was the bed down here, and this was sticking up, I think this would probably print fine. Maybe a little bit rough under here, but that maybe is not a bad thing. Well, we're at 54% on the snap design. Let's just get this exported and sliced. I see. The pipe might be a little bit of a tricky print. Although, to be fair, we could I think for testing purposes, I'm going to slice this in twain and just give ourselves a piece of testing to work with. And then if it works, we can figure out how to we'll cut some in the bottom off and print it that way or something. Yeah, let's get this exported and sliced so it's ready to print when the other print finishes. So we'll export the pipe. We'll export the couplet. And we will come back to Prusa Slicer, which I closed because I was feeling fancy. Shorten the pipe and have it sticking up. Yeah, exactly, Thomas. Yeah, we're thinking on the same wavelength. Pipe and coupler. All right, so orientation-wise, there's our pipe, there's our couplet, and we'll just take a cut out of the bottom of this pipe for planning purposes. Keep upper part, perform cut. There we go. So that's our pipe and our couplet. We'll do an adaptive slice again, sure. Although there's not really anything that needs it. Yeah, Thomas, I'm happy to just print this and find out what happens. I mean, it's going to be a 12-minute print, right? There's the joy, gosh, the joy of 3D printing and iterative design is that it's fast enough that not only can we could do it several times over the course of an evening, but we can do it several times over the course of an evening together across the internet. How cool is that? Well, that's exported. That's ready to go. Looks like we're at 68% on the snap fit there. Of course, I could do a small brass rod for the pipe. I do have some small brass rod. Here, why don't you enjoy... Here, I'll turn the Microstage back on. What I really should have done is put a little rainbow chase on it, and then anytime I was like, instead of tummy cam, it should be Microstage view. And you can just enjoy some delicate RGB lights. But let's see here. Oh, gotta turn the DMX source on for it to be DMX, of course. There we go. All right, so I do have a little brass pipe, I think, let's see, leftover, or at least enough to play with. When my wife and I got married a couple of years ago, gosh, we're coming up on our 2-year wedding anniversary. Where does the time go? One of the things we made as centerpieces for all of the tables and favors for the guests to take home were little projects that were a 3D printed base. I don't know that I have any actually in here. They're all out in our living area. But I can show you the 3D printed part because that was all in Fusion. That was a 3D printed base that was a flower, and then we assembled here in the wedding folder, of course. And yeah, there we go. So we had this base back, and this part was a tight fit to some small brass rod. And then on the front, we hand assembled a bunch of, we've been collecting bottle caps since we got together. We have over 3,000 bottle caps. So we glued them into color coordinated flower shapes in the front, and we filled all the tables with vases that had more bottle caps, and then we stuck them in there, and it was very cute. So I have a bunch of little brass rods and cutoffs for brass rods that we could play with if we wanted to. Thomas says tiny fogger tube. Oh yeah, where? What was that? Oh, I think clearly it's not saved in the correct folder. I wonder if that. For a while, a lot of things were ending up in the My First Project folder. I wonder if it's there. Yeah, so we had a need to mount some fog ducting. I don't know where it is. It could be in any of these folders. Theater models. Some ducting onto the front of a Tiny Fogger brand Tiny Fogger. And so I made an adapter that mounted to the front of one to fit some 3/8 inch PTFE tubing. PTFE? Probably not. Whatever that clear acrylic aquarium tubing, all it was. But like I say, since it's not in that folder, it literally could be in any of them. So probably not the most fun to go hunting for. Let's see. We're at 90% on the previous print. So that's a good place to be. Yeah, I'm gonna pull the don't save changes that the snap fit project back up, and think about. So no, of course I haven't put the oh right. The point of this project is it doesn't need the screw in the middle because it's snapping to the horn that is already screwed in place. So assuming that this part works, and that's a big if, let's think about how this could be turned into a functional design. And I am realizing that as we start to put the pipe onto this, it's going to become a little bit hard to print. but I think that's a solvable problem. So first thing I'm going to do is going to take away this outer flange that we were using to sort of give ourselves a surface to work with. And then let's create a sketch on this face. And let us strike a line across the center here. And we'll do something like this. And this is maybe not going to make sense for a second here, but well, I guess I don't swear that it'll make sense because I have sworn such things before and been made a fool of. But in the interests of keeping this printable, we are going to make sure that the edge of, let's see, so I want this to print probably like this, with this down here being the base. I'll probably do some supports in the middle here. So I really want this to be against an edge that's 90 degrees to this, I'm realizing. Palmer says it's fish tubing? Palmer, I don't understand. It's aquarium tubing, right? Is it fish tubing? Let's see here. So this wants to be like so. And like so. And we'll mirror that across center line. And something like that. So now, so let me extrude this out some to be the start of our pipe. Oops, that's not the faces I want. I want these faces. No, I want 1, 2. So this is going to kind of be our pipe structure here, and we'll print it like this with this face down here flat on the bed, and we'll do some supports in the middle here to make sure that everything is supported as it prints. A little worried about being able to snap without breaking. Yeah, Palmer, you and me both, friend. Yeah, I don't know how that's going to work. Let's see. I'd engage the safety squints when you test the print, which is done. Oh, thank you. Yes, I will. Thomas, are you watching my 3D printer over my shoulder in that camera? That's amazing. Or maybe you just like have a good sense of time and space. Let's pop that guy off. And while I do, we'll preheat the bed and steal the USB stick. A little bit extra adhesive to there. And we'll get Thomas's coupler loaded on so we can get that printing as well. All right, USB. Let's see. We'll get that over onto our flash drive. We'll go to our G-code folder. Oops, we will pull our coupler, etc. Put it on the flash drive. Eject. And we'll get that going. Ah. All right, we'll get that in the printer. It's funny, like, I can tell that this enclosure is doing at least something. I mean, it is just, I think, 4mm or 6mm window insulation. But when I, reach inside it like this to get a new print started, it is, I would guess about 10 degrees. I have had a thermometer in here for a little while. It's a little cheapy room thermometer, and I repurposed that for other things. Mostly telling how cold our house is in the winter. But it is noticeably, I would say, about 10 degrees warmer inside the enclosure during a print, which is a good sign, because that's the idea, is it warms up to a stable temperature and then just stays there. All right, that is printing. So now we can check out. Oh, Thomas was keeping an eye on the printer and saw it was not moving, which is very clever. Here, I'll tell you what. So rather than snap right to this, I am going to grab an additional servo for us to play with, just so we can work on it in free space, as it were, from the big bin O servos. Really, I guess it's just seeing if it snaps to the horn, but testing clearance and fit would also be good. I'll zoom out a little bit here. Let's see. All right, so there's our servo. And there's our horns. Let me grab a screwdriver. And we'll do this like it was the thing. So we'd put the horn on, we would screw it into place with the little tiniest screw. The littlest screw that ever was. And we'll see here. I'll zoom you in. We can get right up and close to the action. So if it does fail, you'll get a real neat view of it zooming off to infinity. So these are meant to snap here. Ooh. May have been a little too aggressive with the ledge of the snap part itself. Like I'm having trouble getting, I think you can see, getting those to snap down around that arm. I could go that way. I can tell that, so I sort of slid this one in from the end, so I can tell the spacing between the teeth is fine, but the ledge is just a little bit too big. Joe Disbro votes force it, which that tracks. I mean, we're gonna force it, but put the bracket on the table, yeah. All right, here we go. Safety up. Let's see here. I mean, if this doesn't work, it's fine, right? The whole point is that it's a prototype. We can always decrease that snapment. Snapment? Is that the technical term? I think the technical term for how far that overhang is the snapment of this design. We can reduce the snapment there. Ugh! Get in there! Let's see. We could. How are we gonna increase the snapment? Oh, I had it. Oh no, I broke it. I was like, oh, it fits a lot better now. That's because I broke it. Dang. Palmer. When the prototype doesn't work, it's an amateurotype. You're killing me, Smalls. Joe says, would you live stream the hospital trip if you injured yourself? No. not that kind of streamer. You won't believe what happens when this tiny moving light streamer had his bracket fail when he was forcing it onto the servo horn. Least clickbait ever. All right, well, so that's not quite right. Let's go over. We'll fix the snapment a little bit there, as we prepare to print another one of these. So let's see. Where would that be? Is that this? No. So this I think is fine. I think the clearance under there is tight but good. I think it is this. So yes, we have 0.4 millimeters of snapment here, and that's what's critical, because you remember this, we don't end up extruding this at all. Let's take that down to like 0.2 millimeters of snapment and check our features. Yes, and the chamfers are going to start failing, but that's okay. So that will be our new shape. So not a lot of snapment, but I think an acceptable amount. I guess, oh yeah. No, I think that'll be okay. And then this will kind of be our pipe structure here. You know, I guess I could take the dimension for this brass rod off of that wedding piece, because I know that fit is really pretty good. I mean, the way that those were affixed in the wedding project was with hot glue, so it's not a perfect fit, but a pretty good fit. And then we could just use this. I guess part of the question is, like, if we start using some of this brass rod as the pipe, how do we get like the little, arms onto it? And that could be another 3D printed part, but at that point it kind of feels like we should just 3D print the whole thing. So if this is the arm, what we need is little hookies. And I think the way to do it is just to... We're basically just gonna make some little army dues, like so. And I guess I want them to sort of be centered on the pipe, because I think when this is hanging in its ready position, it will kind of be like, let's say like this, right? So the curtain's hanging off of here. So we just need some little nubbins coming up this way. Probably actually even higher, probably coming up here to keep that curtain sort of suspended closer to the center of rotation of the servo. So let's put those, I don't know, just kind of here. We'll just kind of slap a thing down, and we'll extrude it, something like that. And we'll probably want to fillet that edge so it slips off nice and easily. Yep, and this can all be made more pretty later for sure, but let's fillet the bottom one as well. Sure. Let's actually, while we're filleting things, let's fillet the attachment to the sort of pipe structure, because that will help make it a little bit stronger. I think that'll be okay. And we will, you know what I'm going to do is, let's see. Could solder some fingers on, that's certainly true. Or do some oh yeah, some little screws that just threaded through the brass rod. That's not a crazy idea. I think if I do a feature pattern here, it's not going to necessarily, oh it is, oh here we go. Yeah, so I want to pattern this whole feature, and I want to pattern it in this direction, and we'll just do like 3 of them for now at, say, 20 millimeter spacing. And that's probably smaller than I would do in the final analysis, but for the sake of like printing it this evening, hopefully, and playing with it, that will be quite good. Just keep it, you know, a small sample section of what we might achieve. So there's our little kabuki pipe kind of a thing. So it would hang like this, and then it would rotate from our view clockwise and tip these fingers down, and the curtain would slide off of it. Yeah. So yeah, so not like a perfect design, and like there's some things that I would probably, you know, want to clean up here, but I think an interesting proof of concept. Thomas's design is at 62, 63 odd %. It's pretty good. So let's get this sliced and ready to go. We'll send this over to, this is the Snap 2 design, and we will bring it into Prusa. Snap 2, so this is the orientation I have been imagining it printing, is rather this. And then we will print with, I will print with supports everywhere. Although these little tiny overhangs are probably fine. I think we'll probably have slightly better results if we allow those supports to fill in underneath here. And it'll make this interior surface kind of rough, but again, that's not necessarily a bad thing, given that that's like our friction interface surface. Oh, this is an 18-minute print. What are we going to do for 18 whole minutes? Criminy crumminy. So here, let's get the other I'll get the other Kabuki mechanism down here, both as like a test bed and as a 18-minute dance break. You know, it's funny, and Chris, you'll appreciate this as a fellow Northwestern associated person. Just today, so like many universities, right? Northwestern, where I was an undergrad, has an annual tradition of like a fundraiser dance marathon that they just call Dance Marathon, where students sign up and fundraise, much like if you ever did like a walkathon, like raising pledges and money. It says like, if you sponsor me to dance for 30 hours continuously to raise money for various charities. One year the Prevent Cancer Foundation or various other Doctors Without Borders, great things. And I was part of the lighting team of Dance Marathon while I was at Northwestern, and it was 10 years ago today. A video popped up on Facebook like, hey, remember 10 years ago? This is when you did that giant sandstorm dance party in a tent for 1,000 college students. And like, that was I think that would be really exhausting to do nowadays, but like, what a good time that was to do. As like, that was a great college experience. It was just like, when you're young and have lots of energy and can stay up for 30 hours and throw a crazy dance, strobe adventure in the middle of it. Wouldn't trade it for the world. Not sure I would do it again, but I wouldn't trade it for the world. Anyway, that's a little trip down memory lane for yours truly. So this is the kind of setup I have been imagining, but I think for the purposes of testing tonight, what might end up happening is like both Thomas's design and the one that I'm kind of roughing in may assume that there's like a second passive bearing out here somewhere, or I guess really for the coupler design, Thomas, 2 passive bearings. So we might just use like this surface on this other Kabuki mechanism as that surface for testing purposes, because it's at approximately the right height. So I'm just going to move it over closer so we have something to test with. Although we'll test fit on the free-floating servo before that. Get in there. Get in there. Click in there. Get in there. There we go. Cookie, if you're watching later on, I think Cookie, who is someone who did the design of all of this 44mm truss, right? And you can find, I don't remember if I keep leaving it in the description of the stream. If not, D3D truss on Prusa printers is this module. Super great stuff. I think he has not been joining us because it's quite late in the evening where he is. But if you're watching later, Cookie, the snapment there, that's my fault with these snaps. Your truss is still great. Thank you. All right, 99%. So I'm going to get up and have a look at our pretty little coupler. It's printing. It's great. Here, I could even get the full experience. Well, you can see the underside of the backup microphone, right? The microphone we go to when the lav craps out on a given evening. Sorry for that. All right, we are done. Let's get the flash drive out. Let's get the build plate off. Let's get the printer preheating again. And before we take a look at this coupler design, oh gosh, I hope you're not, oh god, hello. Should have left it on a different camera view for a little bit. Let's just take care of getting this next design printed. That's probably more up close and personal than we usually get, huh? And that's, I think, for the best. Let's eject flash drive. Let's kind of carefully here. I'll switch over to something else so I don't get all up in your business again there. There we go. All right, we will take the coupler off the build plate. Restore the build plate to the printer. Flash drive goes back in. Something about the Prusa Mini and their provided flash drive, which I'm just using out of convenience, is like it's a symmetrical little metal flash drive. And it always takes me about 6 times trying, like every USB key is hard to put it in the right orientation the first time. For some reason, the combination of the Prusa Mini's USB port and their provided USB key, it takes me like 70 tries to get the USB in the correct orientation. And it's infuriating. All right, let's look at this coupler. So here's our demo servo. Zoom in here. So we'll take the horn off of this one. This is the wrong screwdriver. I want Phillips head. Chances of it fitting correctly? Who knows? Well, let's find out. All right, so yeah, so you can, let's see if I can get this to focus. Can you focus? Yeah, so there's the inside of this print. So it did do some bridging, so a little bit of squirrely in there. Maybe we'll try and just clean that out real quick with some tweezers before we try and put this on the servo. I don't know, what is this brand? Gomvo, I don't know. This was a set of tweezers that came from overseas, clearly. They're great. Like little tiny sharp needle tweezers are a super useful tool on the workbench. I think these were like $6. I'm sure they come in many different assorted brands. So if you, that's a useful tool for, especially for small 3D print work, is like, you just got to get in there and pull something out or pull supports out or position a screw. Oh, hey, Cookie. The chances of this catching on, Thomas, I didn't look super duper closely at your design. I feel like the chances of this catching on fire hopefully are small. Let's see. Ooh. Hey. That's a pretty tight fit. That's quite good. All right, let's get the screw in there. All right, let's screw. Ooh, a little bit of a challenge here. I don't know if you can tell. Oh no, that's the wrong screw. Oh no, that's the right screw. Thomas, my screw heads are slightly bigger than in your model, I think is what's happening. Look, I'm hitting the arms. Oh, I can kind of force it though. I wouldn't hate having a little bit more clearance there, but that was fairly successful. Wow, that actually, Thomas, that went on great. Look at that. I mean, I'm really tight on those screw head. I kind of had to wedge it in there, but that went on really swell. And now it mates with the pipe. Ooh, also a little bit tight. It feels like there's some, oh, you know what it is? It's gonna be hard to see. It's the same, yeah, Thomas, it's the same clearance issue with the screw. So these, I was able to sort of use the screw to force the screw in between those two arms, but these two, I imagine, have the same clearance, right? And those are going to be, like, in a assembly situation, I could force those to be on there. Has a bigger head than, listen, I know I have a bigger head. I'm the one putting my stupid face on the stream for all this stuff. Wow, so contrary to what I would have guessed, Thomas, I think your clearance on the servo attachment is spot on. That worked really well. The clearance to the screw head is just a little bit tight, but I think this idea has promise. I mean, I can use the, use the shaft to turn the coupler, or vice versa, as it were. It just needs a little bit more clearance. So we could go in and make that work really easily. Yeah, that's quite nifty. That's actually, that's a nifty design. Let's go in and we can just, that's a relatively easy change to make because we have Fusion and we have that timeline, which Thomas so generously shared. Let's see here. Where is that Kabuki mount? Kabuki mount. Add a snap connection to that design. Ooh, that's a fun idea. Kind of the both worlds merging there, Chris. Let's see. I want to make this editable. Yeah, so let's see. So let's go in. I'm going to turn this guy off, and we'll see what the sketch is. Here, I tell you what, just to get a sense of what's going on here, I'm just going to roll myself through the timeline. So we imported the servo, we created a sketch, we extruded it around the servo nozzle, we created another sketch, which was, oops. I'm just gonna find the sketch where we create those arms. So a little bit of a cap there, and then I bet it's this. Yeah, so it must be this sketch. Yes. So what I'm gonna do is just offset this face by maybe 0.2 millimeters all the way around. Like it was relatively close. I just need a little bit more clearance. And we will just take that out of the arms. And then this next operation, what have I done here? I've split this in a way that I don't want to. Do I want to be extruding all of these to start with? Possibly. Ah, I see. And then we'll extrude those some more. Yeah, there we go. And none of those. Now, oh, okay. So now this wants to also not include. That wants to include just those original sketch faces. What sketch are we working in? Sketch 3, right? Yeah, okay, there we go. So we'll do that and that, but not this inner portion. And we will turn bodies back on. Yeah, something has gone awry. But oh, I see. I was conflating two operations here because this is a new body operation. Yes, this is the start of the shaft. I see. Yeah, so that's right. There we go. That was correct the first time. Yeah, it's fascinating, Thomas. Like we have two different ways of approaching these problems. I mean, probably more than two, right? Like we have just different styles and like strategies we use. And so I was like, if this was in my strategy, this is how I would do it. But that's not how that works. So let's see. So let me make sure in this extrude, which is where we started making the shaft, that we are not we're including some screw clearance. And I don't think that we are. Let's see. I think this is meant to be. I'm going to turn that body off, and I want to disinclude that surface and that surface. Yeah, there we go. So now we should have clearance around that screw head all the way around. Let's turn it back on. There's our servo. We'll turn off the coupler. We'll turn off the servo body. And we have clearance there now. And we'll turn the pipe off and we have clearance. Oh, we don't have clearance here. I did something wrong again. Maybe, there we go. We'll turn that segment off and that segment off. And now we have clearance there. Okay, so a little adjustment. I would just offset the faces next to the screw at the very end. Oh, also fair. Also fair. How are we doing up here? 42%. Pretty good. You know what I'm going to need, it occurs to me, to test either of these is a curtain of some kind. What spacing did I choose on these teeth arbitrarily here? 20 millimeters, I want to say? 20 millimeters between them. It's a very small... This whole thing is going to be like a 2-inch kabuki curtain, which will be fine. Just check that there's still clearance between the two parts since the last operation. Oh, that's a good idea. Let's see. I think there is. Let me turn servo back off and this. Yes, so there is at least like lateral clearance here. There's not any clearance here, which I don't think there was before, but that'll probably be fine. If maybe a tight squeeze. I do wonder if we could bevel these a little bit and make them just a little bit more interlocking, but I think that's probably beyond the scope of what we aim to accomplish this evening. But that might be a fun thing to get them to sort of lock into place just a little bit. Excuse me, sorry for the camera craziness. It's occurred to me, and you're all, hey, I know a bunch of nerds that could ask a nerd question. As this, as everything has evolved to be a more ambitious way of trying to share this stuff. You know, I think I mentioned before, the software that I use to make this happen is OBS, and various accessories, a Stream Deck that controls it and various things, which is great. But as it becomes more of a multi-camera experience, what I really want, he said, as he looks for material to make a curtain out of, and find some, is almost something more akin to a video switcher. Like, I would love, like, for example, right, and this is, again, a lot of talking about how the sausage is made on this stream, which I know is not what anyone's here for, but it's kind of an interesting thing to talk about as we do other physical tasks, hopefully. Like, right now, for example, you're looking at, you know, a view. I've got a big view of the tabletop. I've got a little view up here of what's on the computer screen, and you have the view of my face. And there are about, I don't know, there's like 6 or 7 different things that could be in each of those spaces now. You know, there's the face here, there's the face over here when we're looking at the computer together, there's the shot of the table, right, that's looking down, there's the what else? So there's the view of the computer screen itself. There's now, this is what started, there's the view of the Microstage. There's maybe going to be an additional camera at some point. Like, there's 6 or 7 different things that we could look at, and I've sort of found the, you know, dozen or so that are most useful. Like, you know, this one where we look at a thing on a table together, and my face is here for vanity. Here, let's look at this side to be a little more visible. But what I find myself wanting, you know, especially when we started looking at the Microstage last week, is I wish I could have a shot right now that was, you know, this view big and this view small and this view small, and I just don't have that pre-made, and so we can't use it. And so I don't know of any, like, easy to use automatable video switchers that I could be like, okay, this view of the table should just now become the view of the Microstage, without having to have, like, pre-planned all those things. Anyway, that's a little, like, behind the scenes. Like, I wish I had the ability to say, instead of just, like, snapping to this preset, that I could snap to, I could control individually what each source was in a clean and reliable way. But I don't know of such a software that would be easy enough to do as a one-person thing, while also trying to, you know, build physical objects or write code. So we'll see what comes of that. 68%. So we're gonna need probably like 3 little holes on 20mm centers. Palmer says, "What's your budget?" I mean, for the right product that was doing exactly those things, I mean, not less than several thousands of dollars. Let's put it that way. Less than $1,000. Probably like a couple $100 if it did those things. And that's also the problem, is like, I know that there are incredibly powerful video switchers out there. You know, like, I could get like a Blackmagic ATEM. Yeah, Chris, I just see you in the chat right now saying Blackmagic could totally do. Do I want to spend the amount of money? Really, what I want is a thing that already exists, but for a lot cheaper than it exists for, which is just, you know, just fantasy. We'll put a hole here, and 20mm and 20mm. I guess we'd center that up a little bit more, or I could just not. So where are? Oh, that's gonna fall apart almost instantly if I put the holes that close to the edge. Let's start again. We will put holes on. This is like 10mm wide. So we'll put one at center on the curtain, 20mm and 20mm. Oh, that's right. Shakes has an ATEM. You guys got the fancy ATEM too, I seem to recall. Because it does the fancy picture-in-picture. Well, I can't see marks of blue fine point Sharpie on black material, Jeff. That was a silly thing to think. Here, we'll do it on the not dark side. Don't go to the dark side. There we go. See? Blue Sharpie on gray. Much, much better. Yeah, I do enjoy the DigiKey ruler, Thomas, for sure. Well, that went great. One more time. I don't have a grommeting kit, and frankly, even if I did, I wouldn't use it for this, I imagine, because I'm lazy. But that would be the tool here, right, is to punch a grommet through these things. I do have a grommeting kit at work, actually, if it comes to it. I could punch a few grommets through. Let's see. How am I going to make a nice clean hole through this thing? Let's just use the old classic punch tool of a screwdriver. So this material, I should say, is marine vinyl. Just out of curiosity. This is actually working okay. Ooh. Someone is calling me. I still need a way to route the audio of the other person into the call, but just speaking. Hello? Hello? Anybody there? Hello? I may have just gotten a spam call from a robot. Didn't say anything. It beeped and booped at me like it was a fax machine, which I hate. I mean, the nice thing about these VoIP numbers, right, is like if it ever becomes not the thing, I'll just deactivate it and it's no skin off my back. I just think that having a VoIP number with Malort in the name is something to be joyous about. Palmer, I have not looked into vMix. I don't think I've heard of vMix. What is that? Someone's trying to fax me? Well, good luck to them. There is a way to set up through VoIP.ms that you can get text messages on your VoIP number.
It's me.
Oh, Jesus. Come in. I thought I heard a weird sound, but I have the noise canceling headphones. It's Mary.
It's me.
Hi.
Hi. It hung up on me.
Oh, it hung up on you.
But I was just letting you know there's pizza in the fridge and half a chocolate cake slice.
Oh, thank you, dear. That's very nice of you. Okay, bye. Everyone says hello. Hello. Dave and Thomas and Chris say hello. Oh my gosh. Thank you. I don't know. I hope you can hear that. There's pizza in the fridge and half a chocolate cake slice waiting for me when this is done. That's delightful. Oh, good point.
Hey, Chris.
Mary says, thanks, Chris. I say thanks, Chris. Thanks for hydration. I don't know if you could tell, that scared the shit out of me when Mary popped her head through the door, and I have the noise cancelers on, like I can't hear much of anything, and I look over and there's just this face, just like lurking in the doorway. Amazing. She truly is the best. Oh, we're at like 99% done on the last print now too. So maybe we'll finish getting this ready. Palmer, before I was so delightfully interrupted with promises of pizza and cake, which is, to be clear, the best kind of surprise, what is vMix? Is it a hardware product? Is it a software product? Just gonna slap a little bit of this Marley tape over this curtain here just to give it this, well, curtain's a really strong word, just to give it a little bit of mechanical reinforcement. Software, like a live mixing kind of environment thing, because that's really what I'm, it essentially is the features that I'm thinking or imagining, right? Thinking of is a strong word. Imagining could exist. It's like a very simple and interactable video mixer. Oops. All right, this is done. Pop that bad boy off. Very good. I think that's probably the final print of the evening. I will at some point pre-print my own version of what we'll call the Thomas coupler, which will only be a little bit confusing because Thomas truss is already a thing, right? Thompson truss? Thomas truss. Tomcat truss? Anyway, I do want to test this out and maybe try a little curtain on it and see how that goes. And I also am just going to be trying to cognizant for myself that I do have work in the morning. So I did have a request from my boss last week. I think I mentioned ages ago this. Oh yeah, Palmer, links are blocked because it thinks you're a robot. Let me pull this coupler off here. Please fix the offset before you try and print again. Oh yes, Thomas, I will go back and make sure that there's actual clearance in there before I actually try and print it again. That's a good thought. Let me put where's my servo horn that I was playing with earlier? And if I can't find it, I only have 50 more in a box here. We're just gonna, as usual, I'm just gonna give up on finding this thing and get another one. And then the first one will turn up, right? That's the theme of the evening. Live production mixer. Yeah, that would be okay, so like the baseline of price, right, as I'm imagining, is like an ATEM, like that basic ATEM unit that I don't know if Dispro's still here. I think Shakes was considering, and then they moved up to the fancier model. I think that one is like $800 for a 4 or 5 input mixer. I don't know. I hope if VMix is less than that, it's already game in my book. Yeah, that fit was really good. It's a little bit. So I think what was really successful about it was like a little bit under tolerance. It was a little bit tight, but because that material, that plastic is squishy, it just like zoop, and fit right on. So yeah, A+. All right, let's see how this. Works. See if this snapment is any better. Oh, yes. Oh, damn it. Be really embarrassing to get this bad twice in a row. Not embarrassing. That's what iterative design is. But be unfortunate. Let's see. Are we snapping the correct way? We're snapping this way. The final score tonight might end up being... Oh, hey, here's a problem. The dimensioning across these small arms is correct. The dimensioning across this arm, though, is not. That's what I'm hitting now. But for the sake of experimenting and seeing if the, what do we call it, the snapment is correct, we can use our old precision mechanical fitment adjuster tool. And give that a little bit better fit. ATEM Mini is 300. Wow. Didn't print your test arm? Yeah, Chris, that's on me. Although I don't know that I necessarily need that. I guess I should have printed that arm and see how it compares to physical reality, right? That would have been a smart test. Ooh, found a new surplus store and scored a beautiful cable trunk for $50 this weekend. A+ cookie. That's fantastic. That's a serious find. All right, let's see if that has improved. Yeah, the snapment is already feeling better. Man, how many weeks has it been since we had a Watch Jeff file stream? Not since assembling Demilight 0.9.2, I want to say. I mean, that can't possibly be true. Someone's going to be like, Jeff, it was last week. But loads of console cases. That's a super cool find. I mean, the sad thing is, right, that's probably because some rental house or venue went out of business, right, with all this. But, a cool find nonetheless. Dave says Mr. File and his roughshod brother Rasp. That works on a couple different levels, and I'm a huge fan. And a 3U rolling suitcase, like a 3U rack in a rolling suitcase form factor. Because that's awesome. That is a super cool find. I mean, Palmer, there's your ClearCom setup right there, right? No more lugging around a 40-pound ClearCom setup. Just like get wheels on that thing. I don't know if that's your problem anymore, Palmer. Joe, there's your solution, Joe. I know that's your problem when you're not making it Alex's problem. Ah, cumbersome though. That's a shame. Yeah, it's just rolling portable rolling racks with rack mount capability in a not awful form factor, because at work, God, there's so much history that at place. We have lots of little rolling racks and lots of different form factors, and a lot of them are like a rolling 16 or 20U DJ rack with a couple of lock on end caps or whatever, and they're great for we got to roll 4 microsiever's and a rack with 3 amps and a storage drawer over to the West Pavilion to do an event, right? Perfect for that. But for just a couple bits of rack mount gear that want to stick together, it's just a pain. Speaking of a pain, we're getting closer, but this is just my night now. I've goofed something in the measurement of the physical device, obviously, right? This should not be this far out of spec. And I should just do a check and see if that's still where we're binding. Yeah, for sure. This is just maybe a full millimeter off, which is embarrassing. But that's just how these things go. If we file it to precision and it fits, it will all be worth it. If we file it to precision and it doesn't fit, it will be less exciting. Just cut the large wings off. Yeah, not a lot of flex in a 3mm coupler. I guess I get nervous about the strength of these things, but like you say, Chris, there's just not they're not. Oh, there we go. Well, no, there we don't go. I broke it again. But I can tell that the snapment is good, right? Look at this arm that's not broken. Look at this side that's not broken and how well that has snap fit around those smaller arms. Look at this side that is broken and it is snapped on the smaller arms. And then it's just sheared because I got that measurement wrong. But it does rotate rather nicely. So the idea, right, is, I guess this would have to be, here, we'll do some more curtain modification. Back to fusion, yeah. Let's see here. I'm just gonna trim this up. Need a bit more space and correct measurements, says Chris. That's really all of it, right? I just do the design better, and it will work. I'm also, why are these I do these at 20mm extent. Not 20mm spacing, so they're on 10mm centers. Well, they'll just hang off of here. We'll hang off the 2 outer pegs. Oof, yeah, that's just completely fallen apart there. Although this fit I'm very happy with. That is quite good. If I had, put the other arm in the same... Hey, now here's an interesting thing. Is there anything made of... look at... this is kind of... evocative. I just happened to be messing around as I broke it, and look at how this sort of slips onto the end of this horn. I wonder if there's a design where one side of this, or it could even be along the long axis, is just a slip-on, and it snaps onto the other side. It's slip and snap, as opposed to snapping all 4 arms. So this side could be particularly beefy in its fitment, and only the one other side is doing a snap. That I somehow have more confidence in than this 4-way snap thing, which is maybe I'm just frustrated because I broke it twice, but maybe that's a better idea. Although, to be honest, I think the most successful thing of this evening has been the Thomas coupler, right? I think that fit was really quite good, and with a little extra clearance around the screw head, I think it'll be really quite good. Yeah, Thomas, or two halves that slip on, could do a slip fit there, and then a slip fit there, and we put a screw right, sort of through those 2 halves. Yeah, that's a total possibility. Yeah, maybe even reusing one of our servo screws to like just secure those two together. That's a neat idea. Yeah, and then what to do about a bearing? So the other thing, so just to like I say, I think we're probably not 3D printing anything further tonight, but I do want to sort of do a little roundup of things that were successful and the things that, like, you know, this is the closest we've gotten to a Kabuki pipe this evening. Things that I'm noticing as we're looking at this is the quote-unquote finished model. So one of the things, obviously, is like thinking about how the curtain itself interfaces with this pipe is going to be super critical. The methodology that we used at Looking Glass that I really thought was quite clever is, if this was our curtain, which, you know, probably the holes are going to be somewhat closer to the top of the curtain, we had, in our case, like a thin, like a 1/4 inch black rope, or maybe, I think the first iteration used tie line and we bumped up to a slightly thicker rope, was basically whip stitched through each of the successive grommets. And then it was not the actual holes in the curtain, but that rope that then looped over the pegs coming off of the Kabuki pipe. And that works really quite well. It allowed the curtain to sort of naturally hang level as long as the pipe was level. And it was really easy to hang because you didn't have to focus on like getting a grommet over a pin. You just sort of like hooked some rope over a peg. So that might be a kind of a fun thing to explore. This coupler obviously needs, you know, either some additional thought or maybe we just punt and go to, I think maybe the Thomas coupler is the way to go, right? And then we'll think about a bearing surface so that the smooth pipe or whatever the pipe structure is, which I've already lost the demo one. Oh, here it is. The pipe structure that we created earlier, right, will need to ride on some kind of bearing, but that's relatively straightforward. And we can figure out what that orientation is and probably create a flat side on this pipe, or a little, you know, a flat surface for this to print on in a horizontal orientation so that the fingers could come straight up from it. That would make it nice and printable. And then thinking, so this was the first thought of a finger design, and if it's going to be like a looped rope situation, I think this is fine. And probably, let's just see for curiosity's sake, like if I'm a little worried about the texture of the 3D print itself causing issues, like if it's gonna get caught on that, but I think this is gonna find a nice length. Chris says printing the pipe limits the length. Possibly, although I'm imagining, you know, much like we're printing, you know, 200 millimeter sections of this truss, probably I'm printing 200 millimeter sections of this pipe anyway, and like pegging them together in some way. Like maybe it's a coupler on either end that is like the Thomas coupler. You know, like I could print 500 millimeters total of this, Thomas couple them together, and honestly, for something like that, even like Thomas couple, put it on a flat surface and super glue it, right? It could become a rigid pipe that way. Only because I do like the structural stability of a brass pipe, and for a, you know, an actual curtain, you know, if we were to take this over to the Microstage arena, like having a pipe of that length might be a little bit more structurally secure. I just worry that like fitting the fingers onto this, although I like the screws idea, but that might be just as fiddly as 3D printing the whole thing, maybe. But more experimentation needed there. Yeah, not entirely sure. I think the idea of this clamp coupler, like clamping around the horn, is worth further experimentation, though maybe not for this project. But the Thomas coupler, I'm absolutely going to steal, because why not? Thanks, Thomas. We'll name it the Thomas coupler in your honor, and thank you. It's neat, and we'll figure out the tolerance and the clearance on it, and it'll be good to go. But yeah, I had hoped. I mean, foolishly, I was like, oh well, we'll have a Kabuki curtain working by the end of tonight, and as usual, I've bitten off far more than I can chew, but some really cool progress, I think, tonight. You know, a couple different coupler experiments, some 3D prints, some thoughts about how we can, you know, sort of accomplish clearance on this servo horn. And I got to show off, like, the Microstage and tell some fun stories along the way. So I feel good about tonight, even if, like, the ending is going to be a little anticlimactic, because it's like, hey, Kabuki! I think that's fine. Yeah, let's wrap it up for the evening, y'all. I think I will be happier, and y'all will be happier with me next week if I get some sleep going into this week, so I'm not just burnt out by next Sunday and be like, this week we're gonna sleep on stream, and it'll be fine. yeah. So, as always, I think I said this a couple weeks ago, but like the nights I come out of this most jazzed are the times when like y'all's ideas and feedback and contributions are really like building the things forward. That's really cool. So thanks for hanging out with me on another Sunday night, being nerds. I love it here. As always, thank you. It's a privilege to be here with y'all, and to have the time to do that is a real gift. I hope you're staying safe out there. I hope you're washing your hands. I hope you're hydrating. I know I have not hydrated nearly enough as I should have this evening, even with Mary's excellent help. I hope you're being well. Hoping you're getting those vaccines when you can. if you can, get them. And you know, washing your hands and stuff, and you're all good people. You're all great. Feel free to like and subscribe if you want to see more of these things. The files for all the things in the Demilight project are on the website, jeff.glass/Demilight. And if you have questions or things you want to see, or suggestions or pictures or Fusion 360 files that I can just rip off, the easiest place to find me is on Twitter @JeffersGlass, which is me. That's my name. I'm Jeff Glass. And have a great night. Bye, y'all.